All right, here we are. Excellent. Okay. The next thing that I wanted to show you, and this is the last thing I'm going to do informally before we roll actually into the official content, is that the Cloud Practitioner Essentials class alone will not let you pass the certification if that's what you're interested in. And my point in saying that is not just about the certification, but in order to be a cloud practitioner, you actually need to do a little bit more outside the class. How much more, you might ask? Well, here's a great ramp-up guide that we co-created with AWS that's yours in perpetuity. Share with your friends. You can tell them where you got it from if you want to. Michael Forster gave it to you, right? Is that these are some of the steps that you actually want to take to kind of round out the gaps around what the class isn't going to cover necessarily. The class will cover some of this, don't get me wrong, right? But this is a step-by-step guide. It's called a ramp-up guide that we co-created with AWS that allows you to use free AWS resources to fill in different areas that the Cloud Practitioner class alone doesn't cover. If you notice, this goes over the fundamentals of cloud, and then you notice that there's a digital training here for Cloud Practitioner Essentials, and then you're in the classroom, so you're in the ILT class. What happened is for years they had a digital training for Cloud Practitioner Essentials, and then people were like, no, we actually need an instructor-led class, not just for the isolation and immersion, but we want someone with real-world experience to answer our questions. And so then notice that actually past step 2, once you get past this class, you learn more about pricing, about the support plans, and then this starts to go more and more into different areas around the compute services, the simple storage service, so on and so forth, until you actually get to the point where you could take the exam at the very end. So I share this because if the other thing is like, hey, I need a reference library of training that I can take, that's what AWS.training is. This is a step-by-step guide of things that you might want to do after the class to round out the rest of your experience. I will tell you, and I could not say this enough, if you did everything here, you would be one of the most rock-solid cloud practitioners I've ever met or worked with in my career. Most people don't take the time to just read the documentation and do the hands-on labs and all this other stuff, and it will spectacularly round out your knowledge of AWS. And if you notice, it's actually only maybe 8, maybe 16 hours at most. It's actually, and honestly, I think it's 12 hours in the average, I think, when I went back and did the math. That's it. If you exclude the training that you're taking right now, if you exclude the classroom training, the one day, I think it's only 12, 16 hours. I think I added it up a while ago, but we keep adding stuff to it. So I just want to make sure you have this as well, so that if nothing else, if this whole day is a complete disaster, and you're like, I didn't learn anything, right, from Michael Forster, you've got the training reference library, and you've got a step-by-step guide for kind of deepening your training. Good? Questions, comments? Okay.
So what was the certification you may have mentioned earlier?
So the certification is the Cloud Practitioner certification that's associated with this general track that you're on, of which the class. And so this is a 65-question multiple choice or multiple right answer exam. It costs $100. It's about 90 minutes to take the exam. And if you're interested in that, let me know, because AWS has official kind of third-party exam questions and kind of steps that they request that you take. The ramp-up guide has most of it, but it's missing the reference exam questions that they ask you to follow. If you're interested in doing that, let me know, and I'll make sure I post that by the end of class. You can get the recommended exam questions that you can get off of Udemy. And thus far, every person who's done what's on the ramp-up guide and has taken the exam questions and passed with a 95%, first time they've all passed Cloud Practitioner. That's not a guarantee, but thus far, every person who's done it has passed, and we're in the hundreds at this point in time since we started doing this. So, yeah. So this is the associated exam. I actually will post that link out so you can have details. Did I answer your question?
Yeah, I'm also interested in that exam as well. So.
Okay. All in chat. So good. So I'll make sure I post the exam practice questions at the end of the day so you can have it. Or maybe I'll do it over lunch so you can take a look at it. Okay. Ready to go forward? Good. Good. All right. Let's see. Pardon me just 1 second. They just released a new version, actually, of this course. So there might be some surprises, but I read the notes and everything, so I don't think there's anything super intense here. So let's talk a little bit about what Cloud Practitioner Essentials is going to cover for us today. Let me shift this little thing here. There we go. And remove all the drawings. Okay. So the goals for the course is a little bit of business stuff, really talking about where Amazon puts your data. And I think the slides are missing one major release that Amazon just did about data centers, which we're going to make sure we round out. They're called local zones, and so we'll make sure we cover that. And then some key services, a conversation about security and compliance, which security was the #1 challenge back in 2006 when Amazon first released SQS and then S3. SQS is the simple queuing service, so think of a really dumbed down kind of like active or RabbitMQ. And then S3 is the simple storage service, which is basically object storage or API storage. And so those were the first services that were released, but people were like, why would I put my data in with you? You know, I don't, like, you're a third party. How do I know you won't use it? What certifications do you have? I work for the government. You don't have anything like FedRAMP or DoD or anything. And then we'll talk about architecture on AWS once we get past security. And then we're going to have a conversation about pricing and then a short conversation around support. You know, the audience could be non-technical, but it basically includes all technical professionals. So this sets the foundation for all the conversations that are to come around this. So introduction to cloud, getting started with the cloud, building in the cloud, securing the cloud, supporting the cloud, and architecting in the cloud. Although I think 5 and 6 may be out of order, but we'll see. It doesn't matter. So we don't have to talk about logistics, because if you don't know where your bathroom is, then we have bigger problems. I hope you know, right? And obviously we're going to take a break at noon. So let me say this, is that we're going to take a break at around 10:30. At noon, we're going to stop no matter where I'm at. We're just going to give your brain a break. And then, so if you need to make plans or communicate that out at 12, we're stopping. And then we resume at 1 o'clock. And then we're going to go until 5. So there's probably going to be multiple breaks in there, usually like 1:30, 3 o'clock, and then we'll go until 5. So it just depends on our pacing and what's going on. Let's typically, I ask that you take notes. I've got a notebook right here, so I highly recommend that you do the same. If you don't take physical notes, take digital notes. You want to be very active in your learning, because this is actually, you're giving me the greatest gift that you can actually give anybody, which is your time. I can give you your money back, right? I can correct a lot of things. I can apologize. I can't give you your time back, right? So just make sure that when you're here, right, make sure to try and be as actively engaged as possible. Interrupt me, ask questions, make it applicable to your world. You literally will have all the slides in that Gilmore Global email that you got that has all the student, the guide, the information. You have all the slides, including some of the commentary. My job is to not only cover that material, but to add some flavor and some individuation to it. You can help me do that by asking questions that are specific to your situation, particularly if we're in an area of relevance. Like if you're interested in security, like Chaitanya, you were just talking about how security was something that you would spend some time in. If you got questions there, if we spent nothing but the whole time just having a conversation about things specific to AWS and security relevant to your environment, then that's a win, right? If we get to architecture and you're like, look, I need to dive into this, that, or the other, or I'm curious about how this works, that's going to be a good day for us, because you have this material to a certain degree already, and we want to make sure that it is individuated and customized to your particular approach and environment. Some questions I won't be able to answer because either they're too advanced, or quite frankly, I may not know the answer if it's a fringe service. But if it's any of the 40 or 50 core services, I probably touched it, right? Even the fringe services I've touched, but I'm not a machine learning specialist. So if you ask me about SageMaker at any detail or depth, I can answer a lot of questions, but I don't have real world production experience with that, even though I've supported ML teams. So just know that as we run through this material, feel free to jump in, ask questions, interrupt. You can type them in chat because I've got the chat window up. And so I'm going to try and make sure that this is as interesting and relevant as possible. And I just want you to join me by that, by being as active as possible as you can. I will ask a lot of questions also, just to make sure that I'm challenging you to either fail and learn or to recall stuff that I think we've already covered. Any questions? Comments? Cool. All right. All right, so let's talk about the cloud. Oh, the cloud. I feel like you could insert a bunch of memes here, right, about the cloud. About like, is it just other people's servers, right? What's the whole big hype about the cloud? Now, just to say this before we get into like their definition of it, Amazon is a north of AWS. Sorry, not Amazon. AWS is a $50 billion annual revenue company. I think they posted 45 million in 2020, and I think they're looking at 60 actually this year, which is crazy, right? COVID has been nothing but beneficial to them. But even before COVID, just to be clear, they were experiencing 20% year-over-year growth. It was ridiculous, like just the amount of growth that they were experiencing. And you might be thinking, well, isn't this just other people's servers? But we had other people's servers. Back in the 90s and the early 2000s, we had managed hosting providers that you could go and get servers from. So, like, what was the difference? Well, the real difference is that this is software-defined infrastructure. This is all API-driven, and it's all self-provisioning, which is kind of like the part that's really kind of like crazy. Is that with a credit card, in about 15 minutes, you can actually get access to a globally enabled account that will allow you to start virtual machines, containers, or serverless applications all over the world, right? And if you know how to use it appropriately, and you can actually work out your issues around data replication, because let's be clear, data always adds a new kind of like distinct challenge to any system, is maintaining state around data. If you can solve that particular issue, you can actually go super global on AWS, and AWS provides a bunch of tools to help you do that. But like anything, when you move from one set of rules to another, you've got to learn what the new rules are. And so that's what we're doing today, basically. So traditionally, there's on-premise, and then, of course, the internet comes along, and AWS launches a service, and Microsoft launches a service, and Google launches a service, and IBM, and now everybody's got a cloud. I mean, I think Heroku back in 2005 was one of the great pioneers of just like SaaS-based application deployment. But then Amazon comes along and says, you know what, we're going to do infrastructure. We're just going to offer infrastructure as a service, and then we're going to do platforms as a service, and now we're doing SaaS, software as a service. But we're going to basically give you internet-enabled, software-defined infrastructure that's self-provisioning. That's one of the greatest definitions of cloud. Before, we were dealing with our own hardware boundaries in our own data centers, and now with AWS, you can't find their hardware boundaries because they're constantly adding systems. People are constantly coming in and coming off, and we keep getting increasing economies of scale with AWS because as they grow and design their own processors and get more lean and more efficient, they're getting better at hosting infrastructure, so prices continually drop. Every year, every other year for certain services. And that's what they've done, is they've revolutionized now so that startups or medium-sized companies, none of them that I consult with are actually using physical hardware. They're all going to cloud first. Now, a couple of them have had hardware requirements that require them to run their own data centers. But even then, they burst in the cloud, or they host their HR systems in cloud, or they keep this product line in cloud, and they keep the other hardware product line in data center. So we're looking at a revolution that's now democratized, right? Meaning that this is now the norm. Cloud is now the de facto first choice for new businesses to host POCs and launch production. They're not doing it in data centers anymore. Well, at least not third-party data centers. They're doing it in the cloud providers. So how does it work? Well, it's simple. You probably know how this works already, right? AWS owns, manages, and secures the infrastructure. They give you controlled access to it, and then they charge you every month for what you use. And by the way, they charge you for what you use. They also charge you for what you ask for. So if you say you want 1 terabyte of storage and you only use 500 gigabytes, you're paying for a terabyte of storage. If you use any of their serverless managed services, then what will happen is that you'll only pay when, like for example, a compute is run, but you won't pay when it's not running. right? You might pay for storage, which is relatively cheap, but like they have, for example, Aurora Serverless, which is a basically hidden server database, an RDBMS. It's either MySQL or Postgres, and you can actually run queries against it, and you only pay for the database outside of storage when a query is run. Otherwise, if no queries are run against it, you pay for no compute against you pay for a minimal amount of compute, right? And so they have a lot of serverless services like that where you don't pay anything unless you're actually running. Otherwise, you're just paying for the low cost of whatever tiny amount of storage you're using. So you provision what you need, and you use what you need, and you pay for what you've asked for, and that's it. But that's the key, right? One of the things that I often run into is people are like, "Why is Amazon so expensive?" And I'm like, "Well, compared to what?" And they're like, "Well, these servers that we bought 7 years ago, they cost us a fraction of the cost." I'm like, "Well, what about the power, the cooling, the data center, co-location, the internet bandwidth? What about the security tools? What about the patching? What about all this other stuff that you're not tracking?" And they're like, "Well, we can't even get costs for that." So one thing to wrap your head around is that unless you can actually do an apples for apples comparison against everything it costs for you to run your servers against AWS, typically Amazon has partnered with companies to do these kinds of assessments. So is Microsoft, so is Google, and you come to find out that these data centers tend to be way more efficient than we are with our own data centers, and all of the operational overhead moves over to these cloud providers, and you're no longer getting woken up in the morning at 3 a.m. because an HVAC failed or because you lost a port on your network router. All that stuff happens at AWS, but it's completely invisible to you, right? You don't even see the blips. There's no interruption of service, and it's pretty rock solid. There are kind of three models, which I kind of alluded to with the startups, which is that you're all into your own data center, you're on premise with somebody, you're all into cloud. Most of us, especially if we've been around for a while as a company, have a hybrid infrastructure, which means we've got a little bit of a data center footprint and maybe a little bit of cloud, or the ratio just depends, right? But like I worked for Honeywell back in 2017, 2018 as the global architect for cloud and containers for their entire company. And, just to say this is that obviously they have an established footprint, but then they were also heavily into cloud as well, into AWS. So, that is the common model that Gartner said most existing companies would be in, is that they would be in a model where they're in the cloud, but they're also in their own data center. So that's hybrid. So then what are the benefits? Well, I'm going to say that there's an official kind of like set of ideas here around what the benefits are for AWS, from AWS's perspective. And it really does actually matter on your business, right? But these are the common benefits that most people experience, is that, you're going to trade capital expense for a variable operational expense. I say variable because you might be running a POC one month and you might see your bill go up by like $500, or even larger if you have a sudden burst of traffic. But that's fine, because with a burst of traffic, hopefully it means that's a burst of revenue as well, right? And then you're going to trade that for like having a static kind of capital expense with depreciation. The difference here also is that if someone says, "Hey, we need 50 servers for our application," you're like, "Why?" And they're like, "Because I'm going to have 100,000 concurrent logged in users at a time." And you go to launch, and a week later, you're like, "Well, we only have 30,000 concurrent users. I don't need 50 servers. I only need 20." With Amazon, you can actually, launch those 50 servers, see how things work out, and then step it down to 20 and give the other 30 servers back, and Amazon's not going to blink an eye. You're not even going to talk to anybody, right? You can grab what you need, give it back, or ask for more if you need it. So this really allows you to be very elastic with your virtual machines, containers, and serverless without having to worry about hardware boundaries. Those days are over, right? I'm not saying that you couldn't, you might say, "Well, I need to launch, 100,000 boxes." And so maybe Amazon's like, "Well, hold on, let's talk about an enterprise agreement for that." But most of us are not launching 100,000 boxes. We're not launching 10,000. We're not even launching 1,000 for a single product, right? We're launching maybe hundreds, maybe dozens of servers at a time. Amazon's constantly lowering the bill. because they're constantly getting better and better. They're even now designing their own processors that are ARM based that are actually even more efficient for the performance and the price point. And so, but even their storage services are constantly lowering prices. They're just kind of constantly getting better and better and making things better, especially from a core infrastructure service standpoint. Now, if you need to guess capacity and then right size it, you can. So you can actually like stop guessing. You can actually just launch, maybe take a guess, right, about what your your capacity is going to be, and then you can see what your capacity actually is, and then just right size it down. You can also enable auto scaling for virtual machines for containers, right? And serverless has that automatically. And what that does is that you can do it off a key metric. So if latency, for example, gets high on your application, you can automatically add more virtual machines or shrink them down if it's like, well, I don't, at 3 o'clock in the morning on Saturday, I don't need 20 servers. I need 3 because of business continuity rules like DR, for example, or high availability. And at that point in time, you can just scale back down to 3, and you're only paying for 3 servers. You're not paying for 20 that you needed for the production workload, right? And that can be done automatically, so there's no human intervention. Auto scaling is that secret sauce that allows you to take virtual machines and add them and reduce them based on certain key metrics, or even keeping a like metric in a certain range. Like if you want to say, look, I don't want you to go plus or minus 10 on 100 milliseconds of latency, and it will add and shrink systems based on the targets and boundaries you specify. So you can basically scale on demand, which is awesome. Since everything is now software-defined infrastructure, you can now provision machines in minutes and seconds instead of having to wait days and weeks to get machines, right? So literally you can launch a system in like, I've watched a virtual machine on AWS boot in 5 seconds, which is ridiculous. Now, it didn't have a whole lot of configuration on it when it booted, but it had like an IDE and everything else it needed to actually function in the image. So it's amazing how quickly you can start resources on AWS. Even heavy virtual machines, like big virtual machines, will start fast by way of comparison. And then you can stop doing operational investment for areas that are probably not core to your business. Like, to be clear, like as a kind of infrastructure geek, I love getting in here and peeling back the infrastructure and running network monitoring tools and using Terraform to kick out this, that, and the other, blah, blah, blah. I love that. I love it to death. It's one of my favorite things to do, actually. It's just to automatically build these building blocks. But like most companies are not going to offer that as a service, so it's not core to their business. Like I just did a big enterprise transformation for an automotive kind of distributor and reseller. Not automotive, sorry. It's a parts distributor and reseller. And, they were like, hey, what should we do here? And I was like, well, I think you should just make a CI/CD platform and have your people focus on that and abstract all those services away to AWS, because your core business is parts distribution. It's not creating CI/CD pipelines. So you should have a couple people who are really good at maintaining this platform and evolving it and offer that as a service. But like, don't host this stuff yourself. Don't go buy GitLab and host it yourself. Don't go host, all the different like requirements, like their own Bamboo and Bitbucket and all this other stuff. It's like, don't do that. You don't need that, right? You can, and I know that we have traditionally done that, but now you can just extract that off to somebody else. And they're like, what about vendor lock-in? That's like, we'll tell you what, you're going to have vendor lock-in anyway. If you buy GitLab, you've got vendor lock-in. If you buy Bamboo and Bitbucket, you've got vendor lock-in with Atlassian. So it's not like you're not going to have vendor lock-in. But here's the deal. Master AWS first, and then if you want, you can add another cloud provider if you don't feel comfortable, if you feel like AWS is not being competitive or taking care of you as a customer. So, but that allows them to stop focusing on data center, on provisioning data centers, on like doing anything related to that. They can just offload it off. Now, sometimes there are legal and security requirements that prevent that from happening, and that's okay, right? Let those services stay in the data center. That's why the hybrid model is pretty valid. And as I mentioned before, you can go global in minutes. We'll talk about Amazon's global infrastructure, but you can kick this out the world over easily, either using a content distribution network or literally replicating infrastructure from one region to another region. Those are locations inside of AWS. And then Amazon has more security attestations, and I mean, it's like ridiculous. We're going to look at Artifact later, which is the in-house library that shows all their attestations and certifications. It's ridiculous, the amount of certifications that Amazon has, and especially even one-to-one. They built out a private data center for the CIA. They have GovCloud, which is private for the government, U.S. government stuff. They've done stuff for the NSA. It's crazy. And at this point, I think all of the cloud providers have done some kind of work for the government. So one thing to not get too intimidated by is that there are a ridiculous number of services in the AWS console. So notice that there's blockchain listed up here on the right-hand side. I think quantum computing is somewhere in here. I mean, most of us are not going to use that. I mean, if you have a use case for it, good for you. But most of us are not in the blockchain business or quantum computing or augmented reality or like robotics. Although I would say that robotics is going to definitely be on the rise. But if we're not running a distribution facility or data center, we're probably not doing that. We're going to focus on a lot of the core services like compute, database, networking, and content delivery, security, identity, compliance, and storage. We're not going to cover satellite or media services or end user computing. We're just not going to do that. That could be a whole multi-day class in itself.
Are you sharing anything?
I am, actually. Can you see my screen?
I cannot.
I can see it.
Okay, I can see it now.
Sorry, I was just talking this entire time and no one could see it. That's weird. Sorry about that. All right, good. Well, luckily there was nothing amazing on any of these slides. They were just reinforcing points for the things I was talking about. But thank you for saying something. All right, AWS Security and Service categories, that's it. Any questions about the why of cloud, about anything about Amazon as a business, any kind of general things around business value for AWS? Okay. I'm going to take silence as a no. Okay. All right, so let's talk about where Amazon could potentially vaguely put your data. All right, I say vaguely because Amazon's not going to tell you where their data centers are. Don't get me wrong. You can probably go on Google Maps and find at least one of their data centers, but they don't tell you where their data centers are, and they try to keep them a closely guarded secret. And anybody who's ever been to one of their data centers is under a strict NDA to not share ever the location, upon penalty of whatever, right? So what happens is that there's about 4 different locations, mainly concentrated in what they call regions, where your services like virtual machines or databases could run. And these are called regional areas, and they're associated with like geographic areas or cities like Toronto or Oregon or California. And actually, if you look on, pull this up here, this might make more sense. If we look at the AWS global infrastructure map, which is actually right on their webpage, you'll see if we look at this, moving past the quadrant stuff, that there's this interactive map that you can actually look at that actually will let you see exactly where AWS is active right now. So here we go. Right now you'll see that they have Canada Central, which is Toronto, right? And they have what they call availability zones that comprise that particular region. So an availability zone is a cluster of data centers that is power cooling, not it wouldn't be cooling, right? But like power cooling and internet fault tolerant to each other. In other words, they're tightly coupled. The data centers in that availability zone are tightly coupled, and they are connected to the other availability zones, which are also clusters of one or more data centers, through these high-speed interconnects. So Canada has 3 availability zones that make up the region of Canada. And so if you look down here on the West Coast, you'll see that Northern Virginia, which was the first data center launched by AWS, has 6 availability zones associated with the region, which means in West Virginia, there are 6 clusters of data centers that they call availability zones, or AZs, that make up the North Virginia region, right? And so a region is really like a cluster of clusters or a meta cluster of data centers. And each availability zone is one or more clusters of data centers that are connected together. Notice here that there are 6 availability zones, which is just, again, data center clusters for North Virginia. They are denoted by letters, by the way. So, for example, the programmatic code for Northern Virginia is US-East-1. So US-East-1. And if I'm talking about a data center, it would be US East-1A or B or C, etc. And so I actually just posted that in the chat so you can see a visual of it. But what this means is that if I want to start resources in AWS in the first availability zone in Northern Virginia, I would click on US East-1A. So how does this play out if you sign into the console? Well, let's go take a look. And actually, I'm going to sign into the console. I also want you to see this just because, if you go to the management, you can just type in AWS Management Console. And then you can click on sign into the console. And by the way, it's going to give you 2 options to log in, which is the account owner, which is the root user. Try not to ever use the account owner for anything. Use it to create other users, but try not to use it. Best practice, don't log in as the root user ever, unless you're are having something that is highly administrative, like adding accounts to other accounts. Otherwise, create an administrative user from the root user, but don't log in as the root user. So you notice I'm not going to actually use the root user. I'm going to use what's called an IAM user, which is an account-specific user. Now, in order for that to work, I actually have to have an alias for my account. Actually, let me blow this up so you can see that better. Sorry. So you can put the account number here, or you can put what's called an alias, and my alias is actually in Forrester. And that means I'm actually in my account, and I have MFA turned on because, yes, that is a best practice also. Please turn on MFA immediately. Not that I've ever had this happen, ever, in my 11-year history of dealing with AWS, but don't ever give anybody access to your account that you don't want to have access to, because they can rock your world from a financial standpoint if that happens, right? All right, so let's see. All right, so now that we're logged in, the thing that I wanted to show you was that if you look on the upper right-hand side, it says that I'm in Ohio. But let me click on Virginia because that's the one we were talking about. Ooh, hey, you reset my thing. Let's come back. So notice it says US East 1. That is the code for the Northern Virginia region. In that region, there are 6 availability zones. How do we know? Well, you would know if you clicked in here and created a virtual machine. But if we go back to the global map, it says there's 6 availability zones. 6 clusters of data centers. Now, if we look at Ohio over here, launched in 2016, 10 years after Northern Virginia, there's 3 availability zones. Most of the regions in the world, whether it's over here in Stockholm, or whether it's in Ireland, or whether it's in Sydney, or whether it's in Tokyo, most of the regions in the world have a minimum of 2 or more availability zones. Here's a best practice. When you launch resources in AWS, like virtual machines, that are availability zone specific, meaning they launch in availability zones, you must span that resource across 2 availability zones if it's a production resource and you want high availability. You must, right? Because if Amazon's going to fail because it'll fail because a data center component has failed, like power or cooling, or someone cut an internet line even though there were multiple redundant. And so you'll if they're going to fail, you'll fail along an availability zone line. And so if you're running in 2 availability zones, if you lose one, then this resource over here can continue running your service, right? So just best practice, run your resources, if they need to be highly available, into 2 availability zones. Every single region has a minimum of 2 availability zones. Okay? Hold on just one second. boy was just grabbing his phone. All right, so this is the global region map, and there are availability zones that make up each of these. Now, the other thing to note is that in addition to these global, like these regions that are comprised of availability zones, each of these availability zones might also have attached to them what's called local zones. So notice here it says local zones. There's 3 of them. What that means is that what they've done is they've taken the concept of the data center, the availability zone, and they've put it in other major metropolitan areas. What does that mean? You're like, what, Michael? What did you just say? Right? It basically says that the availability zones are now sitting in Boston, Houston, Miami, right? That you've now got these data centers now sitting in other major metropolitan cities, but they're associated with the region of North Virginia. Meaning that, for example, if Miami fails down in Florida, you will fall back to Northern Virginia. If the single availability zone in Boston fails, you will fall back to Northern Virginia. Those are called local zones. What that means is that an availability zone means it's in the region, Northern Virginia. But a local zone is an extension where data centers are being put in major metropolitan cities so that if, for example, you have users in Boston that need really low latency access to your virtual machines, you can actually just run your virtual machines in the Boston local zone. But it's not a region, right? The local zone is an independent data center that's just affiliated with another region, in this case, West Virginia. They also have, by the way, local zones on the West Coast. Oddly enough, Oregon has at least 2. I only know one of the cities. Los Angeles has a local zone that's affiliated with Oregon, which is a little weird because there is actually a California data center, the Northern California data center. So I'm not sure why they wouldn't have associated it with Northern California, but I suspect they're going to retire Northern California. So speculation. So just to stop for a second, Justin, I saw that your connection dropped out. What was the last thing that you heard, by the way, before you dropped out?
I believe we were just still on the cloud computing, usually explaining it as far as that. I didn't hear anything after that.
Okay.
Thanks.
And then what was the most recent thing that you started with when you came back? Where was I at?
Oh, you were talking about the availability zones, the local zones, and the metropolitan areas.
Okay, cool. All right. This recording will definitely be available to you, but the first discussion was really about business value and just the different kind of cloud models, like on-premise versus all-in versus hybrid. So, and then Amazon's perspective on the business value that you gain by using their services. So it was just business value stuff. Not to diminish it, but I think you're probably okay if you want to go back and look at the video for it. But please ask any questions about this if you missed something, right? As far as like the regions being like availability zones comprising regions, right? Regions sit in certain geographic areas like Tokyo, California, Oregon, Ohio, that kind of thing. And then availability zones are clusters of data centers that are affiliated with those regions. And then there's this concept that he just introduced last year called local zones, which are availability zones that are affiliated with a region, but they're not in the region. So these local zones are actually at major cities like Boston, Miami, Houston. Those are the first 3 on the East Coast, or Los Angeles on the West Coast. And those are areas where you can also host services like virtual machines, for example.
So those local zones are also as effective as the main zones we have?
So from what I've seen thus far, they tend to have all of the services that the main regions have, with like notable fringe exceptions like quantum computing, for example. They don't have that, but like they have like virtual machines or Kubernetes or containers or serverless. So those local zones look like they have like the majority of the foundational services that are in AWS. Is that what you were asking?
Yes. Yes.
Okay, good. Okay, go.
So when you were to push a resource, you'd have the ability to select multiple availability zones.
Well, it depends, right? Because operating systems can't span availability zones, right? Because that's a single instance of in a digital existence. So you actually, if you wanted to run over 2 availability zones, you have to have 2 virtual machines, right? Because the virtual machine itself can't span across 2 different data centers. It has to live in one data center. So,
Okay.
yeah, and so what you would do is you would do that and put a load balancer in front of it. And then the load balancer would distribute traffic to the 2 virtual machines. Let me show you what that looks like just to make that a little bit more concrete. So if we come in here to EC2, which is the virtual machine service, and we go to start a virtual machine, notice that in Northern Virginia, I don't have any instances running. I have a bunch in Ohio. If I actually come here and I say, look, I want to launch a virtual machine, so I just click launch. The first thing it asks me is a bunch of questions about the operating system. AWS, by the way, supports Mac, Linux, and Windows, obviously, right? Just to mention this, if you use an unlicensed operating system like Amazon Linux or Ubuntu, I think SUSE is licensed, or Ubuntu, then what will happen is you get charged per second for the computer, which is usually like fractions of a penny. It's ridiculous, right? Like you'll get charged like half a cent an hour for like a 2x8 system. It just depends, which we'll cover that in a little bit. If you choose a licensed operating system, you get charged by the hour. So if you start it for 2 minutes and kill it, you pay for an hour of the operating system, of the system. And that's just because of the way the licensing models work with Microsoft and Red Hat and whatnot. So let's say I come in here and I'm starting a virtual machine and I want an x86, not an ARM virtual machine, and I just hit select. I'm going to choose Amazon Linux, which is Amazon's like proprietary Linux. It's remarkably like RHEL, just so you know. And I'm going to come in here and I don't care about the size of the system, so I'm going to choose one that has 1 CPU and 1 gig of RAM, and I'm going to click configuration details, and it's going to say, hey, by the way, you don't really have a subnet, so maybe you ought to pick one. And notice here, by the way, this is where you pick your availability zone. Now notice here I only have 1 availability zone available to me. If I go back to the other subnet, notice that I only have A available to me. This particular section has been pruned a lot. So let me actually show you a better example if I go over to US West 2. Let's start a virtual machine there, and I can actually show you better how the availability zones work. So let's say I'm here and I do the same thing and I select the same size machine, and I want to come in here and I want to pick my availability zone. Notice how all the availability zones are here. So when I start this virtual machine, it's going to live in a subnet inside an availability zone. We're in Oregon. This is US West 2. That's a region. It has 4 availability zones in it. Each of those availability zones has a subnet that I created in there. And so when I run this virtual machine, it's going to live in a specific data center in that availability zone. And so when you start this system, you get to choose which subnets they live on. Now, you can then run systems across all 4 or 2 of the availability zones and put a load balancer in front of it that distributes traffic to the system. So if it's a web server, doesn't matter, whatever, it can be TCP-based traffic, HTTP, HTTPS, doesn't matter. And then that way, when you start this, it will actually live in a specific AZ. Now, if I were to come in here and actually create a VPC in a local zone, then Houston, Miami, and Boston would show up in here as well, if I was in Virginia. Just would be a caveat, right? So once I do this, by the way, I just review and launch. It's going to ask me some questions about security. I just click on launch. It's going to ask me, do I have an ability to log in? And I'm just going to say no, because it doesn't matter to me right now. By the way, Amazon uses public-private keys, so asymmetric key pairs, in order to log into systems. They don't use passwords. So, and then what's going to happen is it's just going to launch this instance. It's going to put it in the subnet that I specified. So most services are availability zone and region specific. Some services are regional, and a very few services are global, which means they run the world over, right? Like DNS is a global service. Username and passwords is a global service, right? IAM is what they call that. So just note that as we're talking about these physical locations where services or data can run, you've got regions that have availability zones and local zones. Then you've got global services, and there's one other type of location other than the availability zones and the regions and the local zones that you can run services. And that, by the way, is these edge locations. Edge locations are where Amazon has put major servers into major metropolitan locations. So this is not a data center. It's just a little cluster of servers, and these servers act as caching servers for content delivery networks, for DNS, for edge computing. If you kick like edge, algorithms out to the edge, like login, for example. And so this is the other like physical location that you could be running services at. So again, to recap, your services could run in availability zones that are inside regions, or it could run in local zones, which are associated with regions, or it can run in these edge locations. Now, I will tell you that for edge locations, most of the time you don't assign services, like you don't assign virtual machines. You can't assign databases to the edge locations. The edge locations mainly work as a caching location. That's what the edge locations are mainly for, is for caching. So those are the three major locations that your data can typically run and where services can be hosted. Again, availability zones inside of regions, local zones, which aren't even listed here inside of regions, and then the edge locations themselves. Questions?
So for what services do we use local zones?
So, local zones are when you want services. Let me bring this up so we can see it. I don't think they took their picture off, actually. I hope they didn't. I think they did. Oh, here it is. All right. So local zones basically are where you're able to host things like EC2, like virtual machines, containers. You can run compute in these local zones. These local zones right now, so you'll notice that here's Miami, here's Houston, here's Boston, here's Los Angeles. These are just like they're availability zones. They're just not in the region anymore. So they're not in the actual region they're affiliated with, and there's only one availability zone. So there's only one data center, right? So that means it's not as fault tolerant as a regional availability zone, because the regional availability zone can fall back to other availability zones, right? This is a local zone, which means it's a standalone availability zone that's away from the region. So what services can you run? Well, let's see. Let's go take a look, actually. AWS services availability. There's an availability map, actually. So if we go look, there's actually a link for a regional services list that actually will tell you what services are available in each particular region, right? And so if we click on local zones, it'll basically say that you can run EC2, which is virtual machines, networking, which of course makes sense, the hard drive service. So it lists actually all the services that are currently available, and these are all foundational services for hosting. So I'll post this actually in the chat, because it's not something that the slides have been updated for yet. But this contains a list of all the services that you would use to run in close proximity to users. So let's say, for example, Chaitanya, that you've got a bunch of users in Miami, like let's say 10,000, and you want to make sure they have a good user experience. Instead of running all your stuff in Virginia, your virtual machines, you could actually put some virtual machines, like your web servers or whatnot, in that local zone in Miami, and the users would hit that server instead of going all the way back to Virginia. So local zones are really useful for people who need to have low latency access to their user base. That's really what local zones are for. And if we go back and look at that map, Amazon has launched currently these 4 locations, and they're about to launch a bunch more locations, it looks like. Right? So it looks like they're about to launch a bunch of other local zones in the United States. So again, availability zones, local zones, and edge locations are the 3 areas where your services or data could reside inside AWS. Other questions?
Can you go over the edge locations one more time?
Sure. And actually, I think they have a good map on their website. Yeah. No, that's usually not what comes up. Hold on one second. Actually, let's go back to their region map, because I think they have. That's local zones. There was the global infrastructure map. Huh. They used to have this great edge location map. They don't seem to have it anymore. Let me actually search their website. No? Anyway, I'll stick with this one then. They used to have a really good one. So edge locations are not data centers. Edge locations are where Amazon has stuck a cluster, has basically put a cluster of servers that have high-speed dedicated backbone access back to their private data centers. And the reason they do that is so that you can actually do caching, like content delivery network. You can do DNS redirection and caching, or you can do actually high-speed transfer acceleration. Let me like looking at this particular thing. Let me see if I can make this work. Is that let's say that you have a user who's over here in Russia, and they go to access something that's all the way down here in Sao Paulo. Now, normally they'd have to traverse this whole thing and be across the public internet. But this little edge location right here, if this one in the upper part of like the Ukraine, Finland, that kind of area was closer, what would happen is that the user from a DNS perspective would actually get redirected here, and then over AWS's high-speed backbone, not the public internet, it would traverse back to the source servers in Sao Paulo, and it would run that back and forth, and then put some cache actually in the server up here, and then any other user in Russia who now goes and accesses this Sao Paulo, the Brazilian service, actually is going to go over here to the caching server to get that file or video or static asset instead of having to go all the way back to Brazil. So that's what these edge locations provide. My messy drawing kind of aside, right, is that that's what they provide, is that it provides quick caching access to data that you specify. What is this good for? Assets that don't change, sometimes API calls if the results are typically static, but JPEGs, image files, video files. Netflix used to use this for their like streaming platform. They used to push all their files out to AWS's CloudFront, and then what would happen is that you would actually hit these edge locations. You would actually go back to the source server. Netflix moved off of CloudFront because they needed to get like their scale was so large that they needed to get more efficient at it. It wasn't an Amazon problem; it was just a problem that Netflix was like, we are like 20% of the internet at 10 p.m. We need to figure this out, right? But these caching locations, these are the edge locations. They're just clusters of servers. They're not data centers that run certain services in AWS. Is that helpful?
Yeah, very. Thank you.
Good. Other questions?
So is the pricing model different across edge versus local versus just a standard availability zone?
That is a great question, by the way. That was Nick, right? Learning your voice. Yeah. Good. Let me turn off the drawing. And so this is actually one of the considerations about why. So with edge locations, you don't. The pricing is flat. You turn on that service and it's fire and forget. You say what you want to cache and it automatically caches the stuff for you. You don't actually choose your edge locations. You can say I don't want to do this in Europe, or I don't want to do it in APAC. You can do that. But you don't get to choose your locations for the edge locations, and they don't charge you differently. So this only applies actually to regions. And I'm assuming it applies to local zones. I actually haven't seen a bill yet for a local zone. None of my customers have been using local zones, and I haven't tested it yet, which I should. So just to say this, there's usually 4 factors about why you would choose a region. 1, compliance. Like if your data can't leave the United States, then you're not going to go over to Europe, right? Or vice versa. You're feeding out, GDPR and all that with the EU. You can't be in the United States, then you're not going to do that, right? Proximity to customers is the other reason we choose data centers. If most of your customers are going to be in Brazil, then you're not going to choose California, right? Services available within the region. So just to say this, if it's a newly released region and you want a fringe service like quantum computing, it's not going to be available in Hyderabad when it comes out, right? When Hyderabad goes live, you're not going to have quantum computing in it. It's just not, right? It's going to be in one of the core data centers because, right, there's more infrastructure there. But the last factor, which I actually think is probably second after data and legal compliance, is cost. So, Nick, just to say this, is that these regions, by the way, for the most part, the costs are all the same. But, like, just to throw this off, California, which is right over here on the West Coast underneath Oregon, obviously, right, you know geography, it's 30% more than the other regions. It costs 30% more to run services there, which is crazy, right? Tokyo over here, right, on the east, you know, in the Asia Pacific area, it costs 30% more than the other regions. But to be frank, there's only certain regions where that's the case. Most of the time, the costs are relatively like localized and flat for the region. But like that's why I said earlier, you may have heard me make a reference that I think they're going to retire Northern California because when they created a local zone there, they didn't associate it with California. They associated it with Oregon. So I'm thinking they're going to retire California because California is 30% more. So there's a couple of regions inside the area where that's like 30% more on 20 to 30% more on costs. So just something to keep an eye on. But if your users are all in California, then you might be wanting to pay that. But most of the time we don't. So there are cost variations by region, but mainly it's specific regions that have huge differentials. Most of the time the costs are very similar. By the way, just to make that easier, if you go to the simple monthly calculator, which I will post in AWS, this is the old calculator that they're trying to retire, but they can't because everybody loves it. I just posted that in the chat. Just to give you an example of your question, Nick, if I come in and let's say I choose one server and it's a T3 2X large, and normally this server would cost me $243 a month. Notice that I'm in Northern Virginia. You see that, right? If I switch this, by the way, notice the local zones are showing up now. If I switch this over to Northern California and I add a server, notice it went from 243 to 290, right? So that's a $47 difference, right? And so you see in that particular case, it's like 20% plus difference, right? That's just for that. Does that make sense?
Yeah, it's good to know.
Yeah. And so same thing here is if we do the same thing and we go over to Tokyo, we'll start with the most expensive one. Same server, a Linux 2.3x large. Notice it's $318, 57 cents, right? If I then switch to something more localized, like not Osaka, but let's say I go to Seoul, for example. Notice it's a little bit cheaper in Seoul, right? Not much cheaper, right? If I switch it over to Sydney, which is also in that area, cost is about the same. So it's about a 10% difference, right, to run it over in Tokyo. And that depends on the service. Like it's somewhere between 10 to 30% more to run in Tokyo versus California. California is consistently like 20 to 30% more. But Tokyo, they've gotten a little bit leaner in Tokyo, so it's gotten kind of come down a little bit more. But it is the more expensive region inside the Asia Pacific. So, check your costs, right? Try to keep it local to your users, but check and see if there's a difference. It might be worth it. Okay, other questions? Okay. All right, that covered, by the way, everything around physical locations. All right, so here's a little quiz for you. I'm going to ask. You can type it in the chat. You can say it verbally. I don't care. There's only 3 of us. It's all right. Or 4 of us. Okay, so what is the subdivision of a region that is associated with the region? What is that called in AWS parlance? Is it an edge location? Is it a local zone? Or is it an availability zone?
Availability zone.
Availability zone.
Availability.
Good. All right. This one I'd actually, if you can, I'd like for you to type this in the chat. Tell me the programmatic, like the code that equals Virginia. Not Virginia AZ, the availability zone, but Virginia the region. What is the
US East 1 or East 2?
East 1. That's exactly right. US East 1, right, is Virginia. Okay. Now, if I was in availability zone 3 in Virginia, what would I add to the end of that code? It's actually in chat. I just realized.
I think I missed this part as far as the code.
No, it's good. So it's US East 1, and then A is for data center, sorry, for availability zone 1, B is for availability zone 2, C would be availability zone 3. So they add letters at the end of the code in order for you to see like what the data center, like the availability zone is actually. One thing to note, by the way, most people don't figure this out until it's a little too late or they do testing, is that if Nick and I have separate AWS accounts and we're trying to get the lowest latency possible between our virtual machines, and Nick starts a virtual machine in US East 1A, and I start a virtual machine in US East 1A on my account, we're in separate accounts, that does not actually put us in the same physical data center. You're like, hold on, Michael. You just said that A was the availability zone linear. Amazon rotates the labels of the data centers because, as you can imagine, everybody either picks the first, the last, or the middle. And so there's a bunch of data centers that don't get used because customers are always sticking with the first or the last or the middle. And so Nick's A for US East 1 might actually be a different physical location than my A in my account. And so Justin and Chaitanya, you might actually have different, your A's might actually be in different data centers inside of AWS, and they do that to distribute load across all their data centers. So just something to know, if you're looking for a high performant connection between your data centers, you might have to do a little bit of testing to actually find out what the lowest latency is between your systems. Most of the time, by the way, that's not a concern. Usually, by the way, it's like single digit difference between the data centers. It's not 10 milliseconds. So it's usually not that big of a deal. Cool. Other questions?
Could you go back to that one slide where it's selecting a region and then 4 different, I would say, variables? Sorry, awesome. Just want to copy that.
Yeah. This is probably, by the way, not in the order that typically I think it's assessed by. I don't think cost is not necessarily the last factor. So. Okay. Good to go forward?
Yeah, I'm good.
All right. Cool. Let's talk then about the 3 different ways that are actually just vehicles for the one way in which you can actually get into AWS, to manage AWS. So first is the management console, which you just saw, right? A few minutes ago. Oh, sorry. I'm out of control. You just saw me actually over here in the console interface, just messing around launching an EC2 instance. Well, let's check on our instance, by the way. Oh yeah, it's up and running, right? It's 2 micro. Deleting is not that hard either, right? Just terminate the instance. Voila, it's gone. This is the one where you choose Oregon, and this is where you can see all the codes listed here, right? US East 1, US East 2, blah, blah, blah. You tend to learn these codes over time. I know the United States codes like that, but like I can't say Cape Town, even though I know it's AF-South 1 because I actually just saw it. But I can't rattle off the other ones per se unless I'm actually focusing on that. So you've seen the console. Like we were clicking around in here, and so you've seen this before. The next one, though, is the command line interface. And the command line interface, actually, let me bring up Bash for a second. Make this really big. So this is the command line interface, and all of it starts with this AWS command, right? And AWS help is your friend if you ever need to like look or find a service in question. But every single service, since everything in AWS is an API, every single service is listed here. So for example, if I wanted to describe all of my EC2 instances, I don't know what region I'm in, but it doesn't matter. See, this is actually giving me a JSON output of this particular EC2 instance, including its IP address, network interface, IPv6 address, and everything else, including any attached hard drives. And notice it's basically telling me the type, the name, the key name, Death Star. That's hilarious. The availability zone that it's in, right? So yeah. So this is a Cloud 9 instance that I have running an IDE actually out in the cloud, out in AWS. And so this can be used, and you can do different things like, if we run help here, which help is your friend, you can actually see all the verbs that you can run against EC2, like allocating host or making sure that you assign an IPv6 address or attaching a disk drive. Make an image of the system. Like you can actually make an image, like an AMI, a bootable image. You could create a fleet group. You can do all kinds of stuff. Change the security groups, change the firewalls, right? Everything that you can do in the console, you can do on the command line and more. Sometimes stuff's not available actually through the console. You actually have to do, very rarely, these specific commands that are only workable through the command line. So that's the second way by which you can access AWS. And I just want to mention is that that's probably one of the most scalable ways to manage your infrastructure on AWS is to use the CLI. The other scalable way is to actually use a software development kit. So you can programmatically access AWS using Python, Go, Rust, whatever. And if you don't want to use the software development kits, you can actually just hit the API. You just have to write your own, submission timers and tokenization and all those other pieces, right? The SDKs kind of make that easier to interact with objects. If you want to know, there's a great little website, AWS. There's a SDK tool site. I'll post this in the chat so you can have it. There's a little tool site that actually will, for your particular language, will link you directly to the SDK. So like Python is the one that I use the most. And so it'll talk about the SDK for Python, the IoT SDK, how to basically add plugins and whatnot to Visual Studio or IntelliJ or PyCharm, sample code for Python if you're looking for that, and then different blogs that are relevant for the Python community, right? There's also, by the way, in the same website, lots of tools for everything, right? Including the serverless application model, which is one of my favorite topics. Copilot. There's, if you want to collaborate around their GoToMeeting Zoom product, there's things for DevOps and automation, such as Code Everything, like Code Pipeline and Code Guru. So they basically have toolkits for practically everything that you would need. So that is an access to the SDKs. The SDKs are just importable libraries that you import into your code that you can then just call functions and objects off of. Those are the three ways to interact with AWS. Console you've seen already. Oh, by the way, I do have a mobile console. It's kind of not awesome. It's not my favorite. I don't really use it, honestly. But
quick question.
It's there.
In real enterprise model, right? So what is the preferred model? Like, is it the SDK or the CLIs they use? How does it go?
For managing AWS at scale?
Yes.
So just to be clear, you're asking like a CI/CD guy. So the preferred method of actually, from my perspective, of managing AWS is infrastructure as code. There's a couple of different options for that. AWS would recommend what they call CloudFormation, which is their kind of de facto integrated way of defining infrastructure. So CloudFormation actually lets you use JSON or YAML to define your entire infrastructure and then just import that into the CloudFormation engine, which will then create all the resources. Let me show you an example so you might get an idea of what I'm talking about. So if we come up here and we actually go to CloudFormation, just so you can get a visual. Oops, and I'm in Oregon, which I have nothing here, so let's switch over to Ohio. Here, by the way, I've actually got 2 availability zones that I created using CloudFormation. I was actually doing a whole Jenkins class, and so I was just helping them get things automated. And so in this case, I actually created an entire VPC using a public template that I modified to create my networking for me because I didn't want to do it manually, right? And so this, if we look at this, this is all in YAML. This kind of thing is Amazon's recommended way of managing AWS. But there's a caveat here. CloudFormation is awesome, and you have to learn CloudFormation in order to automate AWS really well. It's a great practice. But my recommendation is that you use a tool like Terraform, which is done by a company named HashiCorp. HashiCorp writes this Terraform tool that allows you to create cross-cloud templatized infrastructure. Now, don't get me wrong, it's not write once and run everywhere. You have to write it kind of on a per cloud basis. But Terraform is typically the industry standard for how we actually templatize cross-cloud or multi-cloud platforms. So even if you're just in AWS, you use Terraform so that when your boss comes to you 5 years later and says, hey, we need to get into Google, right? You can be like, okay, well, Terraform does Google, so we'll just roll over. So this is probably the other preferred method of managing AWS after CloudFormation. And then the other one, if you're really a type programmer and you really want to stick with that, is this company called Pulumi, which actually does infrastructure as code, but uses the actual Amazon SDKs. And so this Pulumi is an infrastructure as code provider that allows you to provision programmatically if you are a strong coder, whereas Terraform uses a specific domain-specific language, so you don't actually need to know like Python to use Terraform, right? With Pulumi, you need to know Python or TypeScript or whatever your language of choice is. But those are the preferred modern DevOps methods of managing AWS is actually through CloudFormation or through either Terraform or Pulumi. All of those, to answer your question, Shaitanya, is that all of those basically are using the SDK. Those are tools that are using the SDK. Most of the time, though, if we're manipulating, we'll use the command line. If we want to verify visually, we'll obviously use the console, right?
So those YAMLs templates, like what parameters goes and what the limitations and all those things, that is something we have to spend time in learning, or is it something provided by the AWS itself?
So AWS provides a ton of CloudFormation sample templates that you can modify. You usually end up having to customize them for your environment. But like if you go out on GitHub and search, for example, like I'll give you an example. Let's see. What's the name of that company? Witix CloudFormation. Actually, let's go to CloudNots. This company, for example, Witix, also known as CloudNots. If you come out here, you can grab actual working templates for creating your own WordPress site that's highly available, by the way. Jenkins, your own EC2 virtual machines that are, again, highly available. So there's tons of community templates because this has been around for 15 years, right? Well, actually, CloudFormation is, I guess, 10 years old at this point. But still, it's been around for 10 years. So there's tons of like great community templates that you can use. You don't have to start from scratch. So that's what most people do is they grab somebody else's template, read it to make sure there's no security problems, right? And then what they do is then they go through and they modify it for their particular environment. So this is a great kind of company. These guys, I think it's 2 brothers, if I remember correctly, who publish regular templates out, and their stuff works every time. Other people's templates need some modification to function. Their stuff works flawlessly. It's really good, actually. But if you go out to GitHub and search for CloudFormation templates, AWS Labs, for example, is another great site. If we look at github.com, AWS Labs, which is actually by AWS, they have, nope, don't want that. Where are the official, there it is, AWS Labs. If we actually go to AWS Labs by Amazon Web Services, don't be fooled, by the way. If someone else's name is in front of it, that's a copy, a fork, not. But this is the actual verified. They have tons of CloudFormation templates. So they're actually listed right here that you can pull and use. Some are by the community and some are by AWS. If you look in here, if you go by service, there's tons of CloudFormation templates you can pull for this. So I just posted that in chat for you. Does that help?
Yep, this is great. Thanks.
Yeah, good. Okay. So again, three vehicles to just get to the API, because this is all API driven. To verify, use the console. Or if you're just messing around, you just want to learn something, console is a great place. If you are having to manually intervene against systems at scale, use the command line interface. Become competent with that. If you have to do massive scale and need to automate stuff, then usually the CLI and the SDK are used, depending on which tools you use. CloudFormation is the native tool for AWS. Terraform and Pulumi are great fallbacks if you are wanting to do DevOps or you're a straight DevOps coder and you're good with code and you want to use that instead. There aren't really there's other comparable paid for services that you can use, like RightScale and all this other stuff, right? Cloud Foundry, I think, is another kind of good example. Is Cloud Foundry owned by Red Hat, by the way? Is that owned by Red Hat? Or it was at one point in time?
I'm familiar with Pivotal Cloud Foundry.
Ah, okay.
Not IBM.
VMware, I think.
Oh, okay. So is that not the same version that you guys are using, or are you using a different version?
There's a IBM Cloud Foundry, I think, and then we use Pivotal.
Oh, you use Pivotal? Okay, which is now owned by VMware, right?
Yeah.
Okay, good.
Yes.
Okay, so I think we ran through that. Good. Yeah, I don't think I've ever used actually VMware's Cloud Foundry. Or sorry, Pivotal's Cloud Foundry. I don't think I've ever used any of that stuff with Pivotal. I wanted to get into them before, and they were around. It seemed for such a couple of years, and then they got bought by VMware, and then it was missed the opportunity. So here's some key takeaways. One, this is pay as you go. This is utility on demand. So you pay for what you use or what you provision, right? So if you ask for a terabyte, you pay for a terabyte. There's tons of compute power, storage, database services, and other options in here, right? And then your physical, your services are going to run, your data is going to get stored in physical locations, either an availability zone associated with a region, a local zone that's outside the region but affiliated with the region, or an edge location. And the edge locations are, for the most part, you don't assign services or data. That's where caching occurs, right? And there's three ways to access AWS. There's the console, the CLI, and through SDKs. I think we covered that so we're good. Questions of any type around any of these topics? Okay. I was checking the time because I think my timing's pretty good. So it's 10:35. So why don't we take a 15-minute break and come back at 10:50? Unless anybody has any questions or anything before we go. All right. So I'll put a timer up. Actually, come back at 10:51. I'm a big fan of odd times. I'll put a timer up so you know for certain, but it's 15 minutes from now. So go take a break, get away from the computer, grab some water, do whatever you need to. We'll talk again in 15 minutes. Does that work?
That works.
Cool. All right. We'll see you in a bit.
Say I can't hear you.
Sorry, say that again.
Yeah, till now I was not able to hear you.
Oh, yes. Sorry, I had mute on my headset. Welcome back, everybody. So we're getting quite a collection of links here. Can everyone see my screen still?
Yes.
Yeah, I can see it.
All right. Let's see. So that would be module 1. Let's talk about the next module. All right. One thing to note is, let me go ahead and pre-warn the labs here. We'll be doing a lab after this one. The first lab that we're going to do actually is on the simple storage service, which is the API object-driven storage inside of Amazon. It's not actually used to mount inside of an operating system. Like, it's not used as like a block storage or anything. It's actually used to host files and objects in kind of like a data repository that can be instantly web enabled. So we will actually be doing that after this particular section, and then we will be rolling over to lunch. Any questions about anything that we covered in the prior section before we move forward?
No questions from me.
Okay. All right. Let's talk about some services then. Okay. So, as you can see here, which is something I usually do myself, actually, Amazon has what could be argued a ridiculous number of services. Some of which are most of which are in strong states of maturity. Some of which have just emerged and are therefore making their journey towards maturity. When Amazon releases a service, though, it's stable, but it may not have all the features that you're looking for and may evolve quickly towards that state over time. I tend to just keep a watch on services that are interested in me when they first come out and start to really look at them after about 6 months after their release. That's not true for every single service, but for most services, that's true. I don't even touch them really until after 6 months to a year after they've been announced. So they have a large amount of products. So when you take a cloud journey and you're looking to kind of expand into cloud, right? You've either taken one path where you've gone cloud first, and therefore you've done your proof of concept, you're starting setting your foundations, and then you're continually just kind of reinventing yourself, or you've already got a foundation in your own existing data center, and you are starting to migrate in with your first project, set new foundations in cloud, complete your migration in by pulling pieces of your data center that make sense, retiring whatever tech debt or legacy components are there that you no longer are attached to, and then now you're in this space of just continually expanding and reinventing in the cloud and the various services that are available. So one of the first services most companies look at, excuse me for a second, is actually EC2, which is just virtual machines, right? But virtual machines in AWS are really different than virtual machines in, say, VMware, for example. One, you don't have as much control over sizing and pieces like that. But the other thing is that there's a whole huge swath of variety. There are virtual machines that are built with GPUs already folded in. There are virtual machines for ARM and virtual machines for AMD. And there's virtual machines that have no other tenants on them. Meaning you can get a dedicated piece of hardware that just has you on it. It's a virtual machine on a piece of hardware sized for that virtual machine. Nobody else is running on that hardware. You can actually get a physical host in AWS that is managed through the programmatic infrastructure that you can install your own hypervisor onto. So you can get your own dedicated hosts. You can buy physical boxes, but mainly the EC2 service is the machine service, either physical or virtual machine, but mainly virtual machine service. So when you need an operating system and you need an OS, this is the service that you go for. Now, since you can log into the operating system, you are responsible for patching it and defending it if you put it out on the internet in particular, right? Otherwise, if you go like serverless, for example, or managed services, and you can't log into the operating system, Amazon patches it and manages it for you. So EC2 is where you manage the operating system. You actually choose your particular virtual machine. So this is great because you can buy the machines you need, give them back if you don't need them, right? You have a lot of control, right? You get to stop it, start it, reboot it, patch it, modify it, customize it, do whatever you want to it. There's a lot of flexibility in sizing. You see where it says choose instance types? That doesn't even really begin to scratch the surface of the number of instance types that are available with AWS. So there's this great website called ec2instances.info. Just actually got bought by a company called Vantage. Vantage does like billing assessment. Now this looks like an eye chart. I'm just going to tell you. I know it's big, right? But what this does is I want you to notice it says EC2 in the upper left. We're in Virginia. I'm going to switch this to Ohio just for my own purposes. Notice we're looking at hourly costs, not secondly, but let's do secondly, right? Notice that if you're using an unregistered operating system, like an unlicensed operating system like Ubuntu or whatnot, that you can get per second pricing. Otherwise, you pay per hour. This is where you pay for like Red Hat or Windows or whatnot. Notice that the prices are over here. Windows On Demand, Windows Reserved. On Demand versus Reserved, these are different ways to license virtual machines in AWS. By default, On Demand is what most people do. You give them a credit card, you ask for a machine, you get the machine, there's no contract. You want to give that machine back, you can. That's On Demand pricing for EC2. Reservations, or what's known as reserved costs, is when you actually get into a 1 or 3 year commitment with AWS. You don't have to talk to anybody. You can just do it online. And you say, look, Amazon, I'm going to buy this one box in this availability zone for a year or 3 years. And even if you don't use that box, you're going to pay for that box, but you will get a steep discount, 40, 50, 60% in some cases, depending on what your details are, off of the price. So look at this, for example. See how it says Linux On Demand and it's 27 cents and change an hour? If you reserve this, and I believe that the reservation filter is 1 year, no upfront costs, which means you don't pay anything. You just tell Amazon you want this box for a year. And then notice it's 10 cents off. It's actually 101, like 0.101 off, right? So while I would argue that it's not half, it's almost half. It's like 40%, 30, 40% off. Just by saying to Amazon, look, I'm going to run this workload, this machine 24/7 for a year. Give me a discount. And you sign up for it, and Amazon says, okay, there you go. You get a discount. If you go for longer, so notice that this is 0.27 versus 0.17. If I go for 3 years reservation on these virtual machines with no upfront, then what happens is, same virtual machine. Oops. I don't want to select that. Notice it goes from 0.27 to 0.10. That's a steep savings. 3 years, no upfront money, meaning you don't have to put down a deposit or anything. It's not really a deposit. It's like a balloon payment, an upfront balloon payment, right? Notice that the difference in costing at that point in time, right? Same with Windows, right? 45 cents an hour for this system, which, by the way, the system that we're looking at is actually a 4 CPU, 16 gig system. Notice that system in Linux will cost you just a little bit over $0.25 an hour. That's an enterprise class 4x16 system that with the M in front of it. The M means median or general purpose series. That's what the M stands for. Fifth means it's the 5th generation of box. You always want to be using the latest generation. I think they have an M6 series right now. How can we tell? Let's just type in M6 and see what comes up. Yeah. And the letters after the number all mean something. Like this is a Graviton processor, this one right here, the M6G, which means that this is what's called a Nitro-based system that is like super slick and super fast inside of AWS. But this is also an ARM-based system. So if you don't have binaries that can convert over to ARM, it probably won't function very well, right? If we go back to the M5, right? This N, by the way, means that it has NVMe SSD attached to it. This is ephemeral storage. Notice it's listed over here, right? So this is just one of the different flavors of virtual machines. The main thing you want to know outside of the letters after the numbers is just the first 2 alphanumerics, right? The first letter means this is what the system was designed for. And the number means what generation of system is this. So M is the general purpose or median series. R, let's say an R5, for example, is the RAM series. The C series, of which I believe there's C6s now, the C series is the compute series. And the last one to really remember outside of RC, etc., is the T series. So the T3s, which are kind of like test boxes. You can use them for production, but only after you know what you're doing, because these guys have CPU burst limits, which you need to know how that functions to actually run it in production, right? So there's the T series, which is tests. There is the R series, which is the RAM or memory series. There is the C series, which is the compute series. And then there's the M series, which is the median or general purpose series. Now you might say to Michael, okay, other than GPUs, which you haven't even talked about yet, what is the difference between these things? Actually, it's the ratio of memory to CPU. Let me rephrase that. The M, the R, and the C series in particular are really just the ratio of CPU to memory. So for example, the M series has a 1-to-4 ratio. So if you look at that first box, it's 4 CPUs and 16 gigs of RAM. That's a 1-to-4, right? If we go to the C series, that drops actually, and notice that these are 2-to-1s. 2 gigs of RAM for every 1 virtual CPU core. 2-to-1, 2-to-1. See that? The R series is the RAM series, which means that this is an 8-to-1. So notice here, it's an 8-to-1 memory, gigabytes of memory to virtual cores. So notice also that they each have different network performances. Oh, and by the way, the T series tends to follow a kind of like, it kind of varies, but it's like 4-to-1 in some cases, 2-to-1 in other cases. But like if we do just a standard T3 series and we basically sort them off a processor, notice that there's all these varieties that are associated with 2 virtual CPUs, and then it goes basically 4-to-1 at that point in time. So the T series doesn't really follow that rubric. So the T series is test, R series is RAM, M series is median for general purpose, the C series is general compute. Where would you find all this information? Well, if you type into AWS instance types, what will happen is that you will actually get to the instance types page, and there is a listing on the left-hand side over here. Let me make this a little bigger. That shows general purpose, compute, memory, accelerated, and whatnot. Accelerated, by the way, are GPU instances. These have GPU cores affiliated with them. They also tend to have crazy backbones affiliated with them. Notice this is a P4D, right? With a 24 extra large. This is an 8 GPU, 36 core, 1.1 terabytes of memory with a 400 gigabit backplane, a fiber backplane on the back of it. So you can get ridiculously sized small and ridiculously sized large systems in AWS. So you can just pay for the thing you need. Amazon also basically uses a lot of Intel processing. They also use a lot of ARM processing, so x86 and ARM. And they also use AMD's processors, and they also have their own custom processors called Gravitron, which are awesome as well. So just know there's also a lot of processor options. There's a lot of networking options. My main thing is your vendor documentation is probably going to dictate what size system you get. So be less hung up on whether it's a compute optimized instance or a memory optimized instance, or does it have the right ratio of CPU to memory in your system. I would get more attached to that. That's not what I wanted. So you get to choose the size, the t-shirt size, and the flavor of your virtual machine. And it's integrated in with everything. So networking, security, which security is on everything by default. So just be aware of that. You have firewalls around all of your resources the minute you start them, just to make sure that's super clear. And then they do maintain 4 nines of availability for your EC2 instances. If you want more than that, you obviously need to design for high availability in DR. It is super secure by default. Amazon, I could argue Amazon's more of a security company first than anything. And then they say inexpensive. I would prefer to say valuable, because I don't think I wouldn't get wrapped up on the dollars, because if you spend $10 million to make $100 million, then that's totally valuable. Hell, if you spend $10 million to make $20 million, that's valuable, right? So I wouldn't call it inexpensive. I would call it extremely valuable, right? Especially since you now have put all of your core operational failures off on AWS instead of having to deal with that yourself in your own data center. And it is actually easy to deal with virtual machines. Now, maintaining virtual machines is not easy, but starting them up and provisioning them, that's pretty easy. Now, Amazon wants me to tell you that they do have a relationship with Intel. They also have a relationship with AMD. They also have a relationship with their own custom die maker, right? But they do use Xeon processors. If you're looking for specific processor types, you can actually choose EC2 instances that are associated with certain features. Like, for example, AVX, which is used for audio video. Oh man, my brain just stopped working there. Different ways of doing encryption, right? Encryption optimization caches, turbo boost. I got to tell you, I'm just going to say this, and I know this this might be controversial, but probably not so much now. No one cares. Like this, we are moving more and more into a processor abstracted world, especially with Apple going off to the side and ARM having taken over, IoT being on the edge. We are moving more and more to both a processor agnostic and an operating system agnostic world. There's still obviously some ecosystems, particularly if we're in the Microsoft ecosystem, that kind of tie us in. But we're moving more and more away from that. People don't care about that as much. Just run my workload and let's just move on, right? We're seeing that a lot more with companies big and small across the globe. Note that with compute optimized instances, right, depending on which generation they're based on specific processors, Amazon just wants you to be aware that they have feature sets associated with each of these. We talked about before about the C series being the compute series, 5 being the generation number. They also have C6s now. M5 is the median, right? These are also powered by Xeon. They also have versions that are AMD backed and ARM backed, right? Notice again that the 4-to-1 ratio is CPU to memory, right? So, the first thing you usually do, by the way, is you choose your operating system. So you saw me do that earlier where I was in the console and I was out here and I said, you know what, let me go out here and start up an EC2 instance. And when you click launch, the very first question it asks is it says, hi, what would you like to do? Right? It says, which operating system would you like to run? That's literally the first question it asks. And then once you choose your platform, which by the way, you can actually choose the official Amazon vendor images. You can actually create your own custom images. You can actually import them from your data center into AWS. So using VMware import export feature. You can also get them from the marketplace. So for example, if you're a fan of SUSE, which is actually on the list here, but you want to buy it from SUSE from their licensing, you can do that. And then there's community AMIs, which I would highly recommend that you do not use the community AMIs, because unless you have a relationship with the specific AMI creator, you don't know what's on these things. So do not use community AMIs unless you're familiar with who's creating it intimately, and they give you a specific AMI number. Otherwise, I wouldn't use the community AMIs. Okay, knowledge check. Uh-oh, here we go. Before we do knowledge check, does anyone have any questions about what we just covered? Can everyone hear me? Have I been talking the entire time? Yeah.
Good question. So we have these various servers, right? If I'm going towards a certain kind of applications, is there any kind of reference where it says these kind of servers are compatible with this kind of applications? based or video based or so on so kind of thing, or is it something we have to figure out throughout? Like I know like it is computational based and all that, but is there any kind of compatibility kind of checklist that AWS provides?
No. No. I mean, unless you're using something very processor specific, like hardware specific, which most people aren't because we've been using virtual machines for a long time, then there's nothing here that's going to cause any compatibility issues. The only thing that tends to cause compatibility challenges is the operating system, right? Like for example, I was talking to somebody the other day, and like the .NET framework, not the .NET Core or whatever, doesn't actually run on anything but Windows, so they can't put that on Linux, right? So they were restricted to running Windows operating systems for that particular workload. But for the most part, nowadays everything's so cross-platform that it's like, what does it matter at this point in time, right? So there's really no restrictions. The only thing is that do you have the hardware that you need? And by the way, if you start a virtual machine, like just as an example, if you start a virtual machine, let's go back to where I was with EC2. If you go back here and I'm running a T2, like you saw I was running a T2 micro over here. If I'm like, you know what, I made a mistake, I actually need to change the instance size for this, you can actually come in and change the instance size if you like stop it, right? I can actually change the instance type. So if I come in here and stop this thing, which actually probably shouldn't take that long to stop, if I stop it, I can actually just change. Sometimes I can change the family and the actual size of the box. So if you find that you've chosen the wrong physical characteristics, you can actually just change it to a different type, not change anything about the operating system or anything you've installed. And generally, the operating system, with very, very rare exception, will just adapt to the changes and then boot into the new space. It doesn't even care, right? Because the hardware is all the same. It just we've added new hardware, which is why you need to reboot. Because you generally can't add CPUs and memory on the fly to most operating systems. They won't support that. So in general, there's very few compatibilities issues other than the operating system.
Okay, so I think the thing I tried, I think a few years back is like some of the T2 micro or something. I have my application running and I try to move it to something larger, and it kept on saying that it is incompatible. Choose a different server kind of messages I was getting. So I was thinking like if there is any kind of compatibility from moving from one kind of T1, T2 to something else, medium, large kind of change if I want to do, if there are any compatibilities.
So typically now, if you're using the latest generation, there are very few compatibility issues. Like for example, you can see that right now I was running a T3 micro, and on my screen I can actually choose, like I could go to the R series, for example, or like I could go to a really large box. But let's say I went to an M5D and extra large. I could just apply that, and then basically machine type changes, and then I can just boot it, and it's going to go, right? So nowadays, if you're using the latest generations, again, remember, if you change the processor architecture, that could cause problems with your binaries and your operating system, because remember, those are associated, right? But you couldn't do that in a physical data center anyway. So my point being is that other than the processor architecture limitations, like making sure if you're x86, you stay x86, you're not going to run into any compatibility challenges about going from one system to the next.
Got
Yeah, and they used to be, just even 2 generations back, that if you were like on an M3, you couldn't move over to a C3. So there were limitations around being able to virtual machines if you're on an older generation of hardware. But if you're on 4, 5, and 6 of the generation series, generally there's no issue migrating to another system. And very, very rarely have I seen limitations, but I haven't seen any in the 4, 5, and 6 series. So you should be able to move freely, again, as long as you don't change the processor architecture. You change the processor architecture, that's all bets are off. So.
it.
Good. Other questions?
I saw there was a answer automated backup or something like that. I wasn't sure about that one.
Say that again.
On your questionnaire, one of your options was it said automated backup, I think. Automatic backups.
Yeah. So, well, let's take a look at this because we're going to run through these questions. So, one, is EC2 resizable? I think we just answered that question, right?
Yep.
It is, right? Can you hot add additional RAM? Hot add, meaning while the operating system is running.
You answered that one also.
I did. Yeah, the answer's no. You can't do that. It's funny because like with bigger, older, big iron machines like HPs and IBMs, you could do that, but even that was a travesty. So, automated backups. So you can actually set automated backups. Are they automatically running? No, because that's going to cost you money. So AWS wants you to make those decisions. But you can actually. There's actually a product called AWS Backup that will allow you to centrally back up all of your data from AWS just at whatever schedule you want, right? And additionally, you can actually set up lifecycle policies for your hard drives so that they're automatically snapshotted on whatever interval you want to. And that's up to you. You can set the retention policy, you can set the frequency, but you can use backup or what they call EBS lifecycle policies, which is Elastic Block Store, the hard drive service. But it's not automatically done for you. You have to turn it on. The other thing is that we already covered that you're going to pay for the capacity that you use. And you can actually have different storage requirements. So you can actually add a bevy of different storage to your EC2 options, which is something we're going to talk about here in a little bit. All right. So here's another little test. Quiz. What is the letter for the general purpose EC2 machine type? Because T was for test. We saw that there was one out there for compute, one out there for memory, and one out there for general purpose. What was the letter for general purpose? Because it didn't really match general purpose. It actually stood for median.
M.
Good. All right. So then, what was the one for memory? If you're using a high memory ratio system,
M.
R. Good. Yeah. Good. R for RAM, which kind of throws you off because I was like, probably maybe should have used M for that, but whatever. That's fine. And then what was the one for compute? C. Good. And then what was the one that we use for proof of concept for just messing around?
T.
Sorry, I missed that. Can you say that one more time?
T. T for Tom.
T. Yes, T for Tom. Sorry, it wasn't your accent. It was just a little muffled, right? It was perfectly clear, just a little muffled on the mic. So T, the T series. Perfect. All right. So then if you know that, by the way, you know most of the machine types. Now, don't get me wrong. There are tons of other options. There's the P prefix, which stands for, someone told me and I forgot. It's like GPU, right? There's the I and the D series and the H series, which are all about data. IOPS or data warehousing. The H series is the latest, right? And then the accelerated computing has the G, the F. They're all over the place. The ones with GPUs are just all over the place. It's crazy. But mainly, most people, 99% of people, use the general purpose, the compute optimized, the memory optimized, or the test systems, like the T series, right? Those are the ones that most people use. GPU is mainly used by the machine learning folks. Most people don't actually use the storage optimized because they have ephemeral storage or they use cold storage, which most people externalize their databases. If they do, I'm seeing more people use more and more the H1 series, but these are huge boxes, so they're expensive, and which is probably another reason why most people avoid them unless they have really high I/O requirements. So, yeah. Okay. Any other questions before we move on to storage?
What was the general one?
General purpose is M for median.
Medium, okay.
Yeah. Okay. We're going to run through the hard drive service and API-driven storage, and then we're going to roll into a lab. So, okay. So there's a hard drive service. Why? Because when you run virtual machines, you need hard drives, right? That makes sense. And so what's happening here is that you can actually attach a hard drive to one operating system. So it's persistent block storage. There's a file system on this. And what happens is that it's automatically replicated 3 times over, from my understanding. And so if you lose a hard drive, sometimes you won't even know it. One of the other hard drives will step in and start feeding out read and write requests, and you won't even see a blip, actually. Because Amazon has this underlying storage service that just automatically handles failover and replication. So every time you write, it replicates it 3 times, and it has 3 read replicas as a result inside the availability zone. Because one thing to note is that virtual machines only live inside of an availability zone. They don't exist at a regional level. They have to be inside an availability zone or a local zone. And you can't put virtual machines, EC2 instances, inside of an edge location. So it's either a local zone or it's an availability zone associated with a region. So Elastic Block Store works the same way. It can only exist inside of an availability zone. So if you want your data to be replicated to other availability zones, you have to create a snapshot and then recreate the disk into the availability zone, the new one, right? But automatically in the availability zone, they're automatically replicating and backing up your data, so there's no data loss. That doesn't mean you shouldn't have backups for corruption purposes. It just means that they have automatic HA for your systems. There are 4 different drive types divided into 2 families. As you see in the lower right-hand side, one of the families is SSD backed. The other family is mechanical. And there's 2 classes in each of those systems. Now notice it says IO1 and GP2 for the provisioned IOPS and general purpose SSDs. That's now changed where now it's IO2 and GP3 because for the first time since the service was launched, EBS got new versions of the hard drives. But the ST1 and the SC1 down below, those haven't changed. Those are mechanical, predominantly colder storage drives. You can scale up or down in minutes with either the GP3 or the IO2 or ST1 or SC1. And I think you're limited to 16 terabyte volumes. So a single disk in EBS can be 16 terabytes in size. But the IOPS, the I/O that you can get against those volumes, varies widely depending which of these 4 types you're using. So the SSDs are very I/O strong. They have great I/O performance. General purpose, I think, bursts up to 32,000 if I remember correctly. Provisioned IOPS will go up to 128,000. They're about to release a new version of provisioned IOPS called Block Express that will go to 256,000 I/O per second, which is, I mean, that's crazy. And we're not talking about trivial chunk sizes here either. It's not 4K, it's like 256K, which is just crazy to think about from a performance and throughput perspective. So you can scale up and down by adding drives as you see fit. You can add drives live to an operating system because you can plug in hard drives live on any operating system for the most part. You only pay for what you provision. So if you ask for a terabyte, you're going to pay for a terabyte. If you only use a gig, you're still paying for a terabyte. That's on you. You can snapshot your hard drives while they're being used, although you have to be careful with that because if they're used heavily, the snapshot may not be, especially if it's a database, it may not be like on the mark. You might need to quiesce the database, take a snapshot, and then restart it. Or you could just externalize a backup and just snapshot the backup. Whatever. There's tools for that for most databases, right? When you do snapshot a drive, by the way, it changes it from an availability zone existence. The snapshot is a regional existence. So when you copy a hard drive, it actually puts it into a regional cache that then allows you to spin up that hard drive into other availability zones, or you can even copy that hard drive, that image that you've taken of the hard drive, to another region if you want to, which a lot of people do for DR purposes. You can encrypt it. Just know that if you encrypt it and you make a copy of it, the copy is encrypted by default. If you have an unencrypted hard drive and you make a copy of it, the copy is unencrypted by default. But you can always spin it up, encrypt it, and then re-snapshot it. So you can always convert it if you need to. So that's the Elastic Block Store. 2 family types, SSD and mechanical. 4 different types of hard drives. 2 are SSD, 2 are mechanical. And so just know that general purpose I/O, which I'm going to go back up here so we can see it. The general purpose GP3 now, not GP2, is the most commonly used hard drive in the EC2 ecosystem. Provisioned IOPS is probably the second. The other two hard drives are typically used for very rare backup, log retention, data warehousing. But I gotta tell you, most people don't store their long-term data on cold hard drives anymore. They stick it here instead. They stick it on S3. Because with a single command, you can actually get to storage that's probably 1/6 the cost of an EBS volume. So while EBS is used for attaching to an operating system, this is just a data location that you can push log files to or push backups to, and it will just host your data. It's a separate standalone storage service. To give you an example, if we go look at this inside the console, assuming I can find my console, where did I stick it? There it is. Cracking myself up. So S3 operates completely independent from any operating system. So what you do is you come out here and you create a bucket, like let's say the DevOps Cyber Club, and you can stick files out here almost like Google Drive or Dropbox or whatnot, except this is enterprise class storage. So it's got like 11 nines of durability, so it takes them like 100 years to lose one of your like 10,000 files or something ridiculous. But like you can actually stick video files, log files, like this is obviously a JPEG of the Phoenix project, which is a DevOps Cyber Club that we run. Oops. And so just note that this is an externalized storage system. You do not mount this as a drive letter or a mount point inside your operating system. So data is stored as objects within buckets. Buckets can have folders underneath them. And the only limitation is that an object can't be bigger than 5 terabytes. Otherwise, you can put as much data out on S3 as you're willing to pay for. How much does this cost? Well, if we go look at that simple monthly calculator that we were looking at before, assuming that I haven't like hidden it away from myself, which I probably did. Let's just bring it back up again. If we come out here and click on S3, which is the simple storage service, if I put a terabyte of data out here and I'll only touch it about 100 times a month, that data is going to cost me about $23 a month, right? If I remove this, let's say I take this out and I don't do anything with this, and I'm back to 0, and I come into EC2 and I add just a 1 terabyte, assuming I can type, a 1 terabyte volume of just general purpose SSD, notice it's going to cost me close to $100, right? So generally S3 is like 1/4, and there's even cheaper storage classes, by the way, of S3, where you can actually get that down to like 1/50th of the cost for S3 for long-term data storage, right? Long-term. So just know that the reason S3 exists is because it's a cheaper, independent data storage option than storing it in a hard drive on your EC2 instance. This is an independent storage service. So this is the one we're going to do the lab on today, right? Is we're going to do a lab on S3, so you can get access, like you can get an understanding of what S3 actually is, right? So you post this using API, either the command line, the console, or an SDK. You post the file in, it resides there, and then you pull it out as a binary if you need to, right? This is great for backups, log files, application like software versioning and deployment, hosting video files. I actually ran a company where we hosted all of our video files on S3 and fed them out from S3, which was awesome. So it's a great product when you have a lot of objects that you need to create en masse. It's not a high-performant file system. It's not a high-performant storage. It's just good for en masse distribution. So it's good when you have many, many, many objects. You can turn on versioning. You can lock them down so nobody can change any of the files. You can create lifecycle policies that says, hey, if this video hasn't been touched in 30 days, I want you to roll it to a colder class of storage so I can pay less. And then after 6 months, I want you to delete it. Or 3 months, I want you to delete it. So you can actually create lifecycle policies that control what happens to your S3 data. There is a version of S3 that's super cold called Glacier that's used for archival compliance and security storage. And you can serve stuff here long term. It is 1/6 typically the cost of standard S3 storage. So it's really, really cheap. Like that $23 terabyte drive that we're looking, the object that we were looking at before, that would drop to about $6 and change if you put it in Glacier. So you can literally get the storage down. And this is for long-term retention and retrieval, right? And by the way, this is not hot, so you can't get direct access to it instantly. It takes 3 to 5 hours for you to restore that file and get it back, typically, sometimes longer. So this is archival storage. So this is good for just like any compliance, legal, healthcare, long-term data that you just want to keep in case one day the machine learning team wants it, preservations of any type, right? This actually can act as a magnetic tape replacement if you put storage gateway on premise on your data center. So you can actually extend your tape library using a virtual machine so that you can actually write to this on your on-premise data center, which is pretty cool. You can also lock it down so that nobody can change the file, just like you can with S3. S3 Glacier has a lock policy where you can just lock things down and nobody can get access to do anything. They can read it, but they can't change it, right? So there's a number of different storage classes inside of S3, everything from infrequent access to a machine learning tier called intelligent tiering to Glacier Deep Dive, which is like even cheaper than standard Glacier. So just know this ranges from hot API object storage to super cold and frozen API object storage. So you can actually set the storage class or type that you want on the object when you upload the object to your system. I'll give you an example. If we go back to the console and let's say for the Phoenix project, right? If I'm looking at the object and I'm like, you can turn on versioning, for example. I could also turn on object lock and whatever. I could also just change the storage class for just this object. So I could come in here, edit it actually, and it's going to create a copy of the object and move it over into the other storage class. Notice that I can actually put it into Deep Dive and like only ever see it again if I actually need to retrieve it, right? I could also put it in reduced redundancy, or I can see it down to one zone. All of these are cheaper options. They're colder options for my storage. You know, this hasn't been accessed in a while. But just to say, this storage is really cheap. I don't even think I'm paying anything for that, actually. Because Amazon has a free tier to all the accounts. And so I think you get 5 gigabytes of storage free every month. So just know, Amazon has a number of storage classes that lets you get cheaper and more appropriate with your access patterns. By the way, if you don't know your access pattern, but you want to take advantage of this, if you turn on intelligent tiering, Amazon will automatically move your object based on its access pattern to colder storage if it's not touched. And if someone suddenly touches it, Amazon will quick expedite it out of cold storage so that suddenly you can get access to the system in question, or sorry, object in question. So S3 is pretty cool. Been around for a long time, been iterated upon quite a bit as well. A lot of people, by the way, will use S3 to offload their static content from their website so the web servers don't have to host static content, because that's kind of a waste, honestly. You can just let the web servers deal with dynamic content, and therefore you can shrink your footprint. Notice that here in this little design, there's a web server in the center, and it's in some form of networking, which we haven't talked about yet. And there's an EBS volume sitting there, and that volume has data attached to it that's for the web server. But anything that's static, like images or even JavaScript, actually lives on the S3 bucket. So when someone hits the website redirects them to go to the S3 bucket for static content, and the dynamic content is handled by the web application. Instant storage, by the way, is a type of storage that can sometimes come with different types of EC2 virtual machines. Here's the best practice. Don't ever use instant storage if you can help it. Because if that machine crashes, that storage deletes itself and goes away. If it crashes and it's got an EBS volume on it, no data lost, right? The storage system is separate from the host that the virtual machine is running on. With instant storage, the virtual machine's instant storage is actually attached to the host. So if the host fails and the virtual machine has to reboot, you'll lose that data on that instant storage. So if you're using EBS, which is the general purpose and the provisioned IOPS and all that stuff, you're totally fine. But if you decide to use instant storage, please don't. You're just going to cause yourself a world of pain unless it's something you can easily recreate, like temporary tables or whatnot. Okay. Questions of any type about storage?
What is elastic file system in comparison?
Elastic File System is network-based storage, but it's also block storage, but it's NFS, right? So if you're used to using Linux boxes where they attach and mount remote network file shares, that's what NFS is. It's a network file share. So whereas EBS is actually iSCSI volumes that are directly attached to the virtual machine, EFS is actually network, like NFS storage attached across the network. So they both run across the network, but iSCSI is purpose-built for direct attachment, which is what the EBS system is using. The NFS system is using the slightly slower and a little bit more complex NFS protocol, which can still be turned up to be super fast, but EFS is used when you want to share a disk with multiple servers. EBS is really designed for a one-to-one relationship. And there is a Windows version of EFS called FSX. So just FYI. Okay. So let me just check on something really quick. Yeah, we're going to do this and then we'll cover lab 1. Okay. That is not where I wanted to start. Pardon me just 1 second. I didn't mean to go all the way back. I should have hit the other button. All right. Any other questions? So remember, EBS is for one-to-one attachment to an operating system. It is block storage. S3 is API-driven storage. That is not necessarily, it's not attached at all to the operating system. And so you access that through APIs. And then EFS, which was just mentioned, so I'm going to just mention this, is also block storage, but EFS is meant to be attached to multiple systems across the network, whereas EBS is actually direct attached. Okay. Okay, so let's talk about how to secure your data, a little bit about networking. So when you create an AWS account, it ends up inside of a region, inside of a VPC. The VPC is actually a networking unit that you can create inside of a region that allows you to subdivide your account on a per region basis. What does that mean? So like if I was in Virginia and I'm in Ohio, I can actually create virtual private network segments in Virginia and in Ohio that are independent of each other that have discrete networking information. So the same way we're at home, we have our own like subnets inside of our house. It's almost like you can create that same segmentation using VPCs inside each of your accounts. Sorry, inside of each of your regions, inside of a single account. So in this particular case, once they create a VPC, then they can start creating subnets. So if you think of a VPC as a networking pie, subnets are slices of the pie that you create based on the networking information that you gave the VPC. So for example, in this particular case, the VPC, let's say it's a 10.1.0.0 network. These two subnets would have a 10.1.1.0 and a 10.1.2.0 IP address assignment. And then what can happen is that you can actually stick virtual machines inside these subnets, and they can talk to each other or not talk to each other. Sometimes they can talk to the internet, sometimes they won't talk to the internet. But the minute you stick a virtual machine inside of a subnet, it's got a firewall around it. So when you create these VPCs and you put subnets inside the VPCs, which by the way, VPCs span the entire region, but subnets can only live in one and only one availability zone. So you can't have a public subnet that spans across all 6 availability zones in Virginia. You have to create a subnet for each of the 6 availability zones independently, because subnets cannot span availability zones. And so you'd have to stick a virtual machine in each of those 6 if you wanted all 6, if that was your desire. Every time Every time there's a network interface attached to an EC2 instance, which by default there's always one, you get a security group. A security group is a stateful firewall that is attached to your system. So in this particular case, you'll see that it's an inbound security group, right? That's opening up port 80 and 443, and there's another one that's opening up SSH, and there's another one that just allows anything from the other security group to access any port or any protocol on the other system. That's a security group A, security group B, security group C, right? So this allows you to create holes in your firewall so that people can get in to hit your web server, can SSH into your system, or if you really trust it, you can make sure that someone can get into other boxes on all ports, right? Which is what you typically do with like Bastion hosts or jump boxes. So security groups are stateful firewalls that wrap around your EC2 instances, right? So every EC2 instance has a security group. You can only allow traffic in. You can't deny traffic. There's another firewall called a network access control list that operates at the subnet level, not the EC2 level, that you can deny stuff on. But with security groups, which is what we were just talking about, you can only allow traffic in, which automatically allows traffic out, right? But by default, when you start an EC2 instance, the EC2 instance, if it has internet access, can get out to the internet, but the internet cannot get to the EC2 instance. By default, all inbound exposure from the internet to your services is denied. So just remember that's the security default with AWS, is that you're not exposed to the internet. Here's some other examples, more specific. Notice that now we have a VPC, and that VPC has a 10.0.0.0 subnet information attached to it. Sorry, not subnet. Sorry, that's the CIDR address, right? And then what's happened is that the subnets over here, let me actually put a marker so we can actually see what I'm looking at. The subnets right here has now subdivided that 10.0/16 to a 10.0.0/24. Same with here. Now it's a 10.0.1/24. And they've got the web tier out here under a public subnet, and they've got the app and database tiers under a private subnet. By the way, this is the old way of doing things. We do not do this now. We put this on a private subnet as well, and we put a load balancer in front of it, so it's actually exposed to the internet, not these guys. But notice that there's a security group for the web tier, there's a security group for the app tier, there's a security group for the database tier. And so all of this together, right, makes up the security groups for the entire application. So any server that's added to the DB tier security group automatically gets these rules down here, which means that port 22 is allowed from the corporate network. So see that 10.0.16? Notice they're allowing traffic from 10.0.16 to come in on port 22. They're doing it here as well, and they're doing it here as well. Note that they're allowing anybody to come in on HTTP or HTTPS from the internet, because that's what the 0.0 is. And that notice that the app tier is only allowing traffic from anybody who's a member of the web tier on port 6455. And the database tier is only allowing traffic from anybody who's a member of this app tier up here and only on 3306. So you can actually make it so a security group will only allow access from members of another security group. Good way to do it. Questions about that? Okay. All right. So which of the following, now let's check, which of the following best describes the types of data for which S3 Glacier is best suited? So first question, is Glacier a block storage system?
Yes,
No.
but
Nope.
No, it's for S3
That's right. It's
or
object.
archival.
Yeah, it's archival storage, so it's object-based archival storage, right?
okay.
What about is it frequently erased within 30 days? Is that good for archival storage?
No.
No. What about this? Is infrequently or rarely accessed?
Yes.
Yes.
I would kind of think so also, right? Maybe. Although it could be if it's never accessed, right? But I think infrequently or rarely accessed is probably pretty good, right? It is archival, right? It does mean you will eventually retrieve it, right? What about is available after a 3 to 5 hour restore period? Does that match what I said earlier about there being a 3 to 5 hour restore period? Sorry, I just kind of gave that away. I don't know what I was thinking, honestly. So forget I said anything, right? Oddly enough, it is actually for infrequently or rarely accessed data, and it is actually the 3 to 5 hour restore period. You can pay an expedition fee if you want to get it restored within minutes. It's only like 50 cents. But if you do that 1,000 times, as you can see, you probably spend some money on that. Probably not much for an enterprise, but still. You can get it back quickly if you need to. Okay, good. So here's some key takeaways, right? S3 is object storage. It has several different flavors. Glacier is the archival version of S3. If you need to attach a hard drive to your EC2 instance, you're going to use EBS for that. If you want to attach block storage to multiple EC2 instances, you're going to use that service that was referred to earlier that we didn't actually really talk about, which is EFS, right? That's for Linux instances. There's an FSX for Windows instances. Remember that if you want to subdivide your account, you're going to create VPCs, and in those VPCs, you're going to put subnets. Here's a question for you. Answer's right here on the page. Can subnets span more than one availability zone?
No.
They cannot. That's on any test you take, by the way, for Cloud Practitioner. They will try and catch you and say, you just make a subnet that spans multiple availability zones. You can't do that, right? Or make a VPC that spans multiple regions. You can't do that. VPCs are region specific. Subnets are availability zone specific. Good. All right, so ostensibly we're supposed to move on to lab 1, but to be frank, we've only got like 12 minutes left before it's the top of the hour. So here's what I'm going to suggest instead. Let's not do the lab right now. Let's go ahead and start lunch early. And let's come back at 12:50, and let's go ahead, which is basically an hour from now, and let's roll into the lab. Now, one thing I would suggest that if you get just a few minutes over lunch is that we're going to log into a website called webage.quicklabs.com. And you should have gotten an email that said confirm your account. I'm going to post this link actually up here. You should have gotten an email that confirmed your account. And if you don't know your password, just click on forget password, and you're going to use the same email address that you received the email on. And once you're logged in, you should see a classroom setup, which would then allow you to click on Cloud Practitioner, and then you'll see the labs, which I just activated, so you should see labs there now. But we're not going to do that now. But if you get a chance, you might want to click on that link and get logged in. If you don't worry, we'll touch it again in about an hour. Okay? Questions, comments, concerns, anything that you want to talk about before we go to lunch? Cool. Okay. I'll throw a timer up, but we will meet in exactly 60 minutes, same time, same place, and we will move on to the next lab. Thanks, everyone.
I might be late because I have to step out from 7:30 CST, so that will be 10:30 for you. Sorry. So I'll be coming around 12:15.
Okay. So you're going to step out for a meeting and you'll be back?
Yes.
Okay. That sounds fine. That's totally fine. There'll be a recording, and I think you have a peer in the class, so they can fill you in if necessary. But if you have any questions when we're going over the content, I'll be glad to do a quick review, so just let me know, okay?
Okay.
All right. We'll see you in a bit. All right, good afternoon, everyone. Welcome back. Here, I'll make sure I hide my laundry again that my son just dumped on my bed. All right, let's see. Let me know if you're back. Give me a sign.
This is Nick. I'm back.
Awesome. Okay. Brother Chaitanya said he had a meeting, so he would actually be running a little late. So let's dive into our first lab, which usually takes about 30 minutes or so. It's a little less. So, just to check, can everyone get logged in to webage.com, which I'm going to post the link for just in case. Huh. All right. Is there anybody who's not able to log in?
I'm just resetting my password.
Okay. Well, once you get logged in, your options are going to be a little bit different than mine, but you should have options for a classroom to click on. It should say Cloud Practitioner. And it looks, from what I can see, that everybody is registered. And once you're in, you'll have to open the lab up, which they're all activated, so they're all ready to be used. When you open the lab, what will happen is it will take you to the instruction page, and you have to click Start in the upper left-hand side. When you click Start, that will actually start the provisioning process, of which, for some reason, it expired the warmed-up labs that I started earlier, and it may take a minute or two to finish provisioning. But once it finishes, you'll click on Start Lab, it'll start the provisioning process. And then what it'll do is it'll give you a bunch of information on the left-hand side, which you'll use actually during the course of the lab. The instructions for the lab are literally on this same webpage. So as you scroll down, it'll tell you to start the lab, open the console. In this case, we can actually just log in, which I'm not going to click on because I'm already logged in as another user. And then what you do is from task 1 through 6, you're going to create a bucket, upload an object to the bucket, make the object public, manage a bucket policy, turn on versioning for S3, and then you're going to host a very simple static website out of S3 as well. So that's the lab. So go ahead and take a shot at following the instructions. Know that if you miss a step, it will probably cause problems for you, so make sure you try to stay as detail-oriented as possible. And that's what we're going to work on until about 1:20, 1:25. So, any questions?
No, so far.
Okay. I'm here. I'm not going anywhere. So if anything pops up, let me know. Otherwise, we'll go from there.